In the world of software, things change quickly. Applications are updated frequently. We need a way to keep up. That's where automated testing comes in. And Selenium WebDriver is a leader in this field. Selenium WebDriver is like a toolkit for automating web browsers. It lets you write instructions to interact with web pages, just like a real user would. This is powerful because you can test your web applications automatically, saving time and catching bugs early on. Imagine you're testing a login form. With Selenium WebDriver, you can tell the browser to open the page, find the username and password fields, enter the information, and click the login button. All of this happens automatically, making your testing process much more efficient. Selenium WebDriver supports various programming languages, including Java, making it a versatile choice for automation testers. When automating web applications, timing is crucial. Web elements take time to load, and if your script tries to interact with an element before it's ready, you'll encounter errors. This is where explicit waits come in handy. WebDriver Wait in Selenium allows you to tell your script to wait for a specific condition to be met before proceeding. Instead of blindly pausing for a fixed duration, WebDriver Wait intelligently waits for an element to become clickable, visible, or meet any other condition you define. Let's say you're waiting for a button to become clickable after a user submits a form. With WebDriver Wait, you can instruct your script to wait until the button's clickable attribute becomes true. This ensures that your script interacts with the button only when it's ready, preventing frustrating errors and making your tests more robust. By mastering WebDriver Wait, you gain fine-grained control over your script's timing, leading to more reliable and efficient automated tests. Dropdowns are common elements in web forms, allowing users to choose from a list of options. While Selenium's Select class provides a convenient way to handle traditional HTML select elements, you might encounter dropdowns implemented differently, especially in modern web applications. Fear not, Selenium WebDriver offers alternative methods to handle dropdowns without relying solely on the Select class. One approach is to use a combination of clicking on the dropdown to expand it, and then clicking on the desired option from the displayed list. For instance, imagine a dropdown for selecting a country. You can first click on the dropdown element to reveal the list of countries. Then, you can iterate through the list items, comparing their text with your target country. When you find a match, click on that list item to select the desired country. By mastering these alternative techniques, you can confidently handle a wider range of drop-down implementations, enhancing the flexibility of your Selenium automation scripts. As your automation projects grow larger, maintaining your test scripts can become challenging. The Page Object Model, POM, is a design pattern that promotes code reusability and maintainability by separating the test logic from the page element locators and actions. In the POM, each web page in your application is represented by a separate class. These classes encapsulate the page's elements and the methods to interact with them. For example, a login page class would contain locators for the username, password, and login button, as well as methods for entering credentials and clicking the login button. Test scripts then interact with the page objects instead of directly accessing web elements. This separation of concerns makes your tests easier to read, update, and maintain. If the UI of your application changes, you only need to update the corresponding page object class, leaving your test scripts intact. By embracing the page object model, you lay a solid foundation for scalable and maintainable Selenium automation frameworks. Navigating iframes and browser windows. Modern web applications often incorporate elements from different sources, such as embedded videos or interactive maps, which are typically loaded within iframes or inline frames. Handling iframes in Selenium requires switching context to interact with the elements inside them. Similarly, some actions on a web page might open new browser windows or tabs. Selenium WebDriver allows you to switch between these windows to interact with elements on specific pages. Switching between iframes or browser windows is like jumping between different sections of your application. You need to tell Selenium which section you want to interact with. Once you switch to the desired frame or window, you can find elements and perform actions as usual. Mastering these context-switching techniques empowers you to automate interactions within iframes and multiple browser windows, expanding your automation capabilities. Mastering complex interactions with the actions class. While simple actions like clicking and typing are straightforward in Selenium, performing more complex interactions, such as mouse hovering, dragging and dropping, or right-clicking, requires the use of the actions class. Selenium's actions class provides a way to simulate advanced user interactions by chaining together low-level events. For example, to perform a drag and drop operation, you would chain together actions for clicking and holding the source element, moving the mouse to the target location, and then releasing the mouse button. The actions class acts like a choreographer for your mouse and keyboard. You can combine various actions such as clicking, double-clicking, right-clicking, moving the mouse, and pressing keys to create complex interactions that mimic real user behavior. By mastering the actions class, you unlock the ability to automate a wider range of user interactions, making your Selenium tests more comprehensive and realistic. Dealing with browser pop-ups and alerts. Pop-up windows and browser alerts can disrupt the flow of your Selenium automation scripts if not handled properly. Selenium provides methods to deal with these unexpected interruptions gracefully. For example, you can handle JavaScript alerts, which are pop-up boxes with OK or cancel buttons, using the method. This method allows you to interact with the alert box, such as accepting, dismissing, or retrieving its text. Similarly, you can handle new browser windows or tabs that open after certain actions. Selenium's method returns a set of window handles, representing all open windows. You can then switch to the desired window using the method, passing the corresponding window handle. By incorporating these techniques into your Selenium scripts, you can gracefully manage browser pop-ups and alerts, preventing them from halting your automated tests. Automating file downloads can be tricky, involving interactions beyond the web page itself. Selenium WebDriver doesn't handle file downloads directly, but workarounds exist. Configure your browser to download files to a specific directory automatically. This ensures files download to the designated folder in your Selenium script. Timeout management is also crucial in Selenium automation. Timeouts determine how long your script waits for conditions before raising an exception. Use implicit and explicit waits to control these timeouts. Mastering these aspects makes your Selenium tests more reliable and efficient. Selenium WebDriver, with the help of the Actions class, allows you to go beyond simple clicks and perform more advanced mouse interactions, such as double-clicking and right-clicking. These actions can be used to trigger specific functionalities on web pages, like opening context menus or interacting with elements in unique ways. Additionally, you can control the scrolling behavior of the browser window using Selenium. This is particularly useful when dealing with long web pages where elements might be located below the fold, requiring scrolling to bring them into view. For instance, you can use the method to scroll the page to a specific element or to a particular pixel coordinate. This ensures that the desired elements are visible before you interact with them. Mastering these advanced interactions empowers you to mimic a wider range of user behavior, making your Selenium tests more comprehensive and realistic. Writing effective Selenium tests is just the first step. Maintaining them over time is equally crucial. As your application evolves, following best practices for maintainability becomes essential. Write clean, modular, and reusable code. Break down tests into smaller, manageable functions. This makes your tests easier to understand, debug, and update. Use a version control system like Git to track changes. Adopt robust naming conventions for readability and maintainability. These practices help create a maintainable and scalable Selenium framework. In this essay, we've explored essential interview questions related to Selenium Java WebDriver, providing detailed explanations and practical examples. We've covered a wide range of topics, from basic interactions to advanced techniques, equipping you with the knowledge to tackle real-world automation challenges. Remember that mastering Selenium WebDriver is an ongoing journey. Continuously expanding your knowledge and exploring new features will enhance your automation skills and allow you to create robust and efficient tests. As you embark on your automation endeavors, embrace the power of Selenium WebDriver and witness the transformative impact it can have on your testing process. By applying the concepts discussed in this essay, you'll be well equipped to impress potential employers and excel in your automation testing career.